So today let us see the Flynn classification of processor organization. In a multiprocessor organization, many control units will be there and many ALUs will be there. A single ALU can also have many functional units because ALU can have an adder or a multiplier. Then for bringing the data from the memory, it can have a functional component. So an ALU or processing element can have many functional units. So in a multiprocessor environment, the first thing is one or more than control units may be there. Then one or more than one ALUs may be there. So depending on that, we will classify the multiprocessors as single instruction, single data, SISD processors, or SIMD processors, that is single instruction, multiple data processors, then multiple instruction, single data, or single instruction, multiple data. So you have four types of multiprocessors. Let us see one by one. So the first one is single instruction, single data. Single instruction means you will have only one control unit, and single data means you will have only one ALU. So the main memory will have the instruction. From the main memory, the instruction will be taken, and the control unit will decide what it has to do, what control signals it has to generate. So that instruction is decoded and necessary control signals are provided. The data will be provided to ALU. So single instruction and single ALU. And data will be available from the memory to the ALU, and data will be added, subtracted, or multiplied. So in SISD, one control unit will be there, one ALU will be there, one main memory will be there. So in the next case, we have single instruction, multiple data stream. For example, in the case of vector addition, the instruction is to add a vector. That's all. Instruction is only add. But while adding a vector, you will take the first element, you will add. Then you will take the second elements from two vectors and you will add. So like that, instruction is only add, but data will be multiple because a vector will have multiple data. So that instruction is decoded and control unit will be generating the control signals. But for the data, the vector will be drawn from the memory. So if you have n vectors, all the n vectors will be added using different ALUs. Actually, processing element means ALU. So you will have multiple processing elements, single instruction, multiple data. That means multiple processing elements will be there. So since the multiple processing elements are there and multiple data are to be used, the memory is divided into n parts. So from each part, one data will be taken. Then in the third case, multiple instruction stream, single data stream. So what does it mean? Multiple instruction means there will be multiple control units. You see here, CU is control unit. 1 to n. Single data means from the main memory, only one data will be flowing through all the processing element. The data is flowing through, is processed by PE1, processing element 1. Then it will pass through PE2 like that. Finally, the result will be written into the main memory. So multiple instructions, single data. Single data means processing elements may be many, but same data is passing through all the elements. Next one is multiple instruction, multiple data. See, whenever you are having multiple instructions, control units will be multiple. Many control units will be there. So for each control unit, one instruction will be provided. You see this. So from here to here, it is going one instruction to this control unit, one instruction to this control unit, then nth instruction is going to nth control unit. And each control unit will have a processing element. That means one ALU. And ALU gets data from the memory. So the main memory is divided into many parts because you need multiple data from each part of the memory. Data will be going to the ALU. You can say like this: single instruction, single data means you will have one control unit, one ALU, and main memory is a single main memory. In the case of single instruction, multiple data, instruction is only one, so one control unit, and multiple data means multiple processing units or ALU. For each processing unit, one memory part will be used. If it is multiple instruction, you will have multiple control units. Single data, each control unit is having a processing unit, but the same data is flowing through all the processing unit. That is why we are calling it as single data. Even though there are many processing units, same data is flowing through all the processing units. Multiple instruction means you will have many control units, and each control unit will have a processing unit, and each processing unit will get data from the main memory. So that is the difference. Among these things, this single instruction, multiple data is a very important one, because most of the latest processors will be using this type of multiprocessor organization. This type of organization is very much useful for doing vector operation.